Welcome to Programming in Modern C++. We are in week 2 and we are going to discuss module 10. In the last module, we talked about ad hoc polymorphism of operator overloading, which is a very key concept, key extension over C for C++. It allows operators to be treated as operator functions and allows them to be overloaded in the context of a enum or a structure. It cannot be overloading, cannot be done for the built-in types, but for others it is possible, and we discuss the rules for that. We will again take up another very core area today in this module, which is dynamic memory management in C++. And I know you all are familiar with the dynamic memory management in C using malloc and free. So, we will start with that and then talk about how to do these things in C++ and how to do them better. This is the overall outline, you will find always on left. So, dynamic memory management in C. I am sure all of you know that you can dynamically allocate memory at the runtime, a memory of a basic contiguous size through the use of malloc function, memory alloc function, where you pass the number of bytes that you want in the allocation. The allocation is done in the free store or heap as we refer to it, and the allocation is contiguous. Malloc is a function available in this standard library. So, you need to include stdlib.h. Right. Malloc, once malloc allocates, it returns you a pointer which is of void type. So, if you are allocating an integer, which is what is obvious here, because I am passing the size of an integer. If it is 4 bytes, then I am passing 4. Then malloc returns a void star pointer, which needs to be cast to the integer pointer. Right. Malloc will always return void star. So, I cast it to integer pointer, and p is now a pointer to this dynamically allocated integer. By dereferencing, I assign a value 5 to that, I print it, I can see. Once I am done, I can free this memory up back to the system by calling free on this pointer p. Exactly the same code can be written in C++, only you need to change the naming of the header. There are other functions in C also, like you have calloc, you have realloc and all that. All those are also similarly available in C++. We will not go into details because you already know all this. I just gave this example as a starting point for the discussion. So, let me jump into the memory management, dynamic memory management in C++. So, this is the C scenario. You use malloc, pass the size, cast it to the appropriate type, the pointer type, and free to free up the memory. In C++, you have a new operator, new. It is a new addition. So, new is an operator, like size of is an operator, new is an operator. Very interestingly, the operand of new is not a value, it is a type. So, new is an operator, is a prefix operator, comes first. Its first parameter, which is mandatory, you cannot have new without this first parameter, is not a variable or a value, it is a type. Very, very interesting, right. Then it has optional other parameters. Here this parameter means the initialization value. So, what it does the same thing as, very similar thing as malloc, let me not say same thing as malloc, similar thing as malloc. A space is allocated which is adequate to hold an integer. 5 is placed in that, initialized here, not assigned later on, it is initialized with 5, and then you get a int star pointer returned, which you are initializing p with. So, some key differences. Okay, so the key similarities both of them, malloc and operator new, allocate on heap. But the key difference is malloc is type oblivious, does not understand the type. So, malloc has to be categorically told, give me so many bytes, that is all, you do size of and do that. But operator new is type conscious, that is its first parameter. So, since it knows the type, it does not need to be given the size, because it can compute internally. If it is int, size of int it knows. So, it knows how many bytes it has to do, right. Similarly, when malloc returns, malloc is returning you an array of bytes. So, there is it is again type oblivious. So, it returns you a void pointer, but here new knows the type. So, you returns you a pointer of that type. So, this int, the type is used in two places, one to compute the size, other to return a pointer of that same type, no casting is required. Further, new can take additional parameter, like as we have given here as initialization. So, the value is not only created in the free store, but is also the variable is also initialized. Nothing like that can be done for malloc. Now, obviously, corresponding to new, there has to be a similar operator to release the memory, and that is called delete. Again, delete is an operator, again delete is a prefix operator, but unlike new, it does not need to take any type, because it takes the pointer that it has to release, and you know the type of the pointer. So, you know what to do with that, how much size was there and how much to be released and so on. So, that is a parallel of free, where free also works with the pointer, but it treats it simply as a byte array. There is a deeper question as to delete would be able to know how many bytes to free up release, because delete knows the type p. Free is again type oblivious, it is in C. So, the parameter of free is void star. So, you can pass p, you can actually pass it like this also, that will also work. Then the question is, how does free get to know what is the size? So, there has to be some mechanism, we will talk about it at some point of time. Finally, the malloc and free are C standard library support, whereas new and delete are operators, so they are language support. So, in C++, memory management becomes a core of it, which was not, dynamic memory management becomes a core part of the language, which was not there in C. Okay. So, having said that, let me again introduce you to something interesting as well as little confusing. Do not get confused, I am telling you, please do not. It also has, C++ also has two functions called operator new and operator delete. very confusing, right? When you say new, it is an operator. When you say operator new, it is a function. So, when you use this, and this is, mind you, this is not the operator function of new. This is not the operator function of new. Operator function of new is also will be there, but this is a separate function. Operator new, it is its name, and since its name is operator new, you need to write operator here. If you simply write new, it means the operator new, not this function. So, what the operator new function does? It behaves like malloc. So, it is a kind of, you can say it is a mimic for malloc. It takes a size, allocates the number of bytes in the free store and returns a void star pointer. Similarly, there is operator delete, which takes a void star pointer, returns a void like free. So, these are corresponding ones. So, that actually in C++, you should not require to use any of the C dynamic memory management functions. Now, the question is, what if you have to allocate memory for arrays? What do you do in C? In C, there is only one way, you can have a byte array. So, you put element size, you put the number of elements here, multiply, that is a total byte size, and get that allocated, get a void star pointer, cast it to the array type, and because a pointer is an array. So, when you get it as pointed to int, you can use it as A0, A1, A2 like that as an array. Free is similar. Here in C++, you have another operator called array new. So, this operator is array new. It is operator new with square bracket. This part remains same. The first parameter is a type. Within square bracket, the second parameter is the number of elements that the array will have. So, this is something additional for C++. C did not give you any mechanism to specifically allocate memory for arrays. It says that let us give you a chunk, you decide whether it is a single element or multiple elements. I have given you convertibility between pointer and array, do whatever you want. But C++ one tells you exactly, needs you to tell whether you want an isolated variable and or whether you want a array variable. And for the array, you can pass the actual number of parameters. I am sorry, actual number of elements. Similarly, you have an operator delete, array delete now, in which you have to, after delete, you have to write this array symbol and then the array name, and that will delete all the elements, release the entire array. Right? It will do a lot of other things, we will slowly come to that. So, we have seen three things so far. One is operator new corresponding with operator delete. One is function operator new corresponding with function operator delete that parallels malloc and free, and one is array new corresponding to array delete, which is specifically for dynamic allocation of arrays. Right? So, you can see that basically the dynamic memory management has been dealt with lot of importance in C++, because that is a key area of performance and quality of code that you can write. The story did not end here. There is yet another operator that is called placement new. All earlier operator new or operator new function or array new, all of them dynamically creates the memory and gives you. So, it is all in the free store. Placement new is not that. Placement new is where you provide the memory and it gives you the appropriate pointer from that memory. It is not dynamically created. The user provides the memory, and as if the operator places the object in the memory that you have given. Right? The example will make it clear. Here is a memory chunk that I define. What is that memory chunk? It is a byte array. Unsigned character is always 1 byte. So, it is a byte array called buff. And what is the size? How many bytes will be there? Size of int times 2. So, it is enough for 2 integers. That is how I have created. Right? So, what I want? I have this array and I want to dynamically create 2 integers one after the other in this buffer, not create them in the free store, not in the heap. So, the difference that I make is again new. It has to have the type, but before that within a pair of parentheses it takes a pointer to the memory where it will do this new creation, and that is buff. So, if I let me try to draw it here, say assuming that int is of size 4 bytes. So, this is from 0 to 3 is 4 bytes, place enough for 1 integer, and 4 to 7 place enough for the second integer. This is buff. So, what I have given? I have given buff. So, I have given this pointer to this placement new operator, telling that give me an integer created at this location. Normal new would have got this address from the system by interacting with the free store, the memory manager of the system. Here I have given that address. So, what happens is the pointer that I get back, since I have given int, it is a int star pointer, has to be the same new behavior, is same as this. So, my integer is here. The third parameter is the initialization value. So, over this 4 bytes, the value 3 has been written in the integer format, and I get that pointer. The second I want is I want the second integer to be created in the next 4 bytes. Second integer to be created in the next 4 bytes. So, I again do new. This is my pointer now. Second integer has to come here. How do I get that pointer? This is buff, and I have placed one integer. So, size of int. So, this pointer, this is buff plus size of int, buff plus 4. So, I pass that as a pointer where the integer should be created. I pass the initialization value 5. So, over these 4 bytes 4 to 7, 5 is created, and I get back this pointer as q int. So, it is all like new, except the fact that I have provided the memory. I have told how objects are to be placed. There are deeper consequences of this, which you will be able to understand once we have talked about the actual object creation and destruction and those processes. Then we will come back and revisit this again, but for now just understand this. So, what now if I try to look at these 2 addresses, one here and one here, the two integers as we have kept. I have taken the buffer address by taking buff plus 0, which is my first integer, casting it to int star. I have taken buff plus size int, this integer, cast it to int star. So, these are the two direct buffer pointers, and these are the two dynamic allocated integers in my address space. And then I have printed the buffer address and this dynamic address to show that the buffer address and the integer address would be same in both cases, which is what is expected. That is the behavior of the placement new. And if you dereference these and print, you will find the initialization values 3 and 5. Okay. You must have got shaken. So, just to clear your mind that this is not happening in the heap, in the free store, do a normal new int 7. This new int 7 is not placement, it will do in the free store. So, you get a completely different type of address, which is a free store address. Right. There is a major thing to remember. One is when you do new, it is dynamically given from the system. So, you need to do a delete to release the memory. But when you do placement new, you have provided the memory. So, the system does not know where that memory came from. Like here I have given this buffer, which is a local variable of the function, which means that the buffer is on stack. So, this dynamically created objects have actually been created on stack, and when this function goes out of scope, when the function returns to its caller, at that time the stack frame of this function containing this buffer will be deallocated and the memory will go. Right now, we cannot remove this memory, because it is a part of the stack frame which is active. So, which means that allocations by placement operator new should never be deleted. That is one protocol you will have to remember. Now, what is the specific use and all that will come slowly. Just we are getting familiar with the different ways of handling dynamic allocation in C++ as compared to what we had in C. So, now you have too much of allocators and deallocators, because all C functions, C dynamic memory management functions are in C standard library. So, anything that is in C standard library is available in C++, you know, right. So, you have all of them available. So, you have to have a very strict protocol of how you use them, particularly in terms of allocation and deallocation. For example, any allocation which is done by new must not be released by free, or any allocation that is done by malloc must not be released by delete. They are completely different functions, their internal data structures are different, the management is different, the consequences of this is unforeseen. And since it is, these are all runtime calls, compiler has no way to check that you are not freeing a memory by delete which was allocated by new. It is user's responsibility to ensure that there is no shortcut on this. So, always match your allocator with deallocator. If you have done malloc, use free on that memory. If you have done operator new, use operator delete, that is one element allocation, deallocation. If you have done array new, use array delete, do not mix between them. Doing array new and doing operator delete, not doing array delete is unpredictable results. If you have done placement new, do not do a delete. Right? Remember these things very clearly, because many of you while developing programs with dynamic memory will often have these problems mixing, and you will have get into difficulty. I would also say that please make it a practice not to use this at all. You do not need them. Just use the C++ ones. Also note that null can be passed to the delete operator. It is not an error, and well, everything else we have talked of here. Right? Now, the last that I want to mention in terms of this is these are the operators as given, but since these are operators, they can be overloaded, and it is okay to overload them for several reasons. So, here is example of overloading operator new and operator delete. Now, operator new must have this minimum signature. By minimum, what I mean is its name is operator new, its first parameter will have to be a size t parameter, in which the compiler actually passes the size of the type that it is getting, right? And its return type must be void star. Again, how that void star becomes the int star that you are getting is a mystery that we will solve later on. So, with this you can now I have written an allocation function here. I have done a malloc of n bytes. I could have used the operator new function also with n bytes, and I have returned that void star pointer. But additionally, I have just printed a message to show you that you are actually using your overloaded operator. Similarly, for operator delete, the mandatory part of the signature is void star, the first parameter, which is the pointer that you are deleting, and the return type has to be void. You cannot change these things, but you can add more parameters, though adding more parameters to delete is not recommended. There is not much use for it, but you can obviously add more parameters to operator new. Right. Now, without that here, now you do new int. This new int, since it has been overloaded, this new int will now call your operator new. So, the new int not only gets you the integer pointer, but it also prints the operator new message. Similarly, when you do delete p, it prints this overloaded delete message, overloaded new and overloaded delete messages. So, that is proof that your overloaded operators are working. Right? You can overload similarly array new and array delete. So, rules are the same, the operator name, operator new, array symbol. The first operand is mandatory, which is size t, return type is void star. Just for illustration, I have introduced another parameter, a second parameter. In this second parameter, I am passing a character. And what is the semantics? What I want? What I want is once the array is allocated, it must be filled with that character, all elements. Right? So, what I do first is allocate using operator new function, something which I did by malloc. This is just for illustration, you could have used malloc here also. Get the pointer, and then I am doing this to fill up with this character, which is 1 byte, and naturally the array I have got is of bytes. So, I do a memset. Memset is a function available in string.h. Right? So, which takes the pointer and the character and the size fills it up, sets into that, simple way. So, everything has been filled by hash initialized and then I return T. This is different from the default behavior of array new operator. This fill up mechanism is not there. In terms of delete, I do not do any additional smartness except that I am releasing memory by operator delete function. Could have done free also, right. But try to use the matching one always. So, now when I invoke, I pass the type, the number of elements, and this the syntax is little bit little bit this way that way, like the first parameter comes at the end, which is the size, the number of elements, and the second one comes at the beginning and type sits in the middle, but that's the way the syntax is worked out. It's a little complicated syntax, so but you will get used to it. So, here I am passing the character that I want as a filling character. So, when I do this, the T star array that I get, and this is just to print the address of the array to show you, and then I write every element going through the loop, and you can see that I am getting all these hashes, 10 hashes, because I have initialized with that. So, this kind of gives you an idea of what you can, I mean you can like this set v, cat set v, you can have more parameters also. You can say okay, my every even place should be one character, my every odd place should be another character. You can do any kind of any number of parameters and so on. All that you will have to do here, this got cluttered. Here within this parenthesis, you will have to put comma and provide these parameters. But you can give your own meaning of dynamic allocation and deallocation for operator new as well as operator array new. You can do the same thing for placement operator also, but you usually will not need that. Right? So, that is about the dynamic memory management here. So, we have introduced new and delete for dynamic memory management in C++ and understood the difference between operator new and operator array new, operator delete and operator array delete, also the operator function, placement new, and the basic protocol, the discipline of their use between C and C++, malloc with free preferred, you never should use, new with delete, operator array new with array delete, placement new not to be deleted. Okay. So, this is the basic way. There is a lot more of core object oriented part of C++ which will get integrated with this dynamic memory management subsequently, but this is with the built in types, with the types that you have in C, you can use these operators in C++ and build your dynamic management completely in C++. Thank you very much for your attention, and we will meet in the next module next week.